வெல்கம் பேக் கைஸ். ஸோ இன்றைக்கி வந்து நம்ம பார்க்க போகிற ப்ராப்ளம் வந்து 5.18. ஓகே, ஸோ இதுதான் ப்ராப்ளம் ஸ்டேட்மெண்ட். The bob of a pendulum is released from horizontal position if the length of the pendulum is 1.5 meters. What is the speed with which the bob arrives at the lowest point, given that it dissipates 5% of its initial energy against air resistance? Okay, ஸோ இதுதான் ப்ராப்ளம் ஸ்டேட்மெண்ட். ஸோ நம்ம வந்து ஒரு drawing வரைஞ்சிருவோம். ஸோ இனிஷியலி the bob is here, இந்த இடத்துல இருக்குது, இதுதான் ஹரிசாண்டல். ஓகே, ஸோ இது லேட்டர் சம் டைம் இங்கே இருக்குது. ஓகே, ஸோ இந்த திஸ் இஸ் த லோவஸ்ட் பாயிண்ட். ஓகே, ஸோ த லோவஸ்ட் பாயிண்ட் இதுதான். ஓகே, ஸோ ஹரிசாண்டல் டிஸ்டன்ஸ் வந்து எவ்வளோனா இட்ஸ் 1.5 meters. That is the vertical distance between the lowest point and the horizontal. அது வந்து 1.5 meters. So this distance is 1.5 meters. Distance between this and this point. Okay. ஓகே, ஸோ இந்த பாப் லோவஸ்ட் பாயிண்டில் இருக்கும்போது. ஓகே, ஸோ நம்மளுக்கு இது முன்னாடி இந்த ப்ராப்ளம் சால்வ் பண்ணியிருக்கிறேன், தியரியை எக்ஸ்பிளைன் பண்ணியிருக்கிறேன். ஓகே, ஸோ இந்த ஹையஸ்ட் பாயிண்டில் இருக்கும்போது இந்த பாப் வந்து ரெஸ்ட்டில் இருக்கும். ஓகே, தேர்ஃபோர் அதோட கைனெட்டிக் எனர்ஜி வந்து 0. சின்ஸ் வெலாசிட்டி ஈக்குவல் டு 0, கைனெட்டிக் எனர்ஜி 0 இந்த இடத்துல. ஆனால் இங்கே மேக்ஸிமம் பொட்டென்ஷியல் எனர்ஜியில் இருக்கும், விச் இஸ் ஈக்குவல் டு மாஸ் டைம்ஸ் acceleration due to gravity and the height is 1.5 meters. Okay, so இது இங்கே against air resistance is coming down. So இங்கே வரும்போது it has maximum kinetic energy. So when it reaches the lowest point, it will have a maximum kinetic energy given by half mvf square, where vf is the final speed. ஸோ இங்கே இடத்துல பொட்டென்ஷியல் எனர்ஜி 0, கம்ப்ளீட்லி 0. ஏன்னா ஃபுல் லைட்டை யூட்டிலைஸ் பண்ணி ஃபுல் பொட்டென்ஷியல் எனர்ஜி இஸ் கன்வெர்டட் இன்டு கைனெட்டிக் எனர்ஜி. ஓகே, ஸோ நம்மளுக்கு கன்சர்வேஷன் ஆஃப் டோட்டல் எனர்ஜி படி நம்மளுக்கு என்ன தெரியும், இனிஷியல் எனர்ஜி வந்து ஈக்குவல் டு த ஃபைனல் எனர்ஜியாக இருக்கணும். ஓகே, ஸோ இங்கே ஒரு பாயிண்ட் நம்ம மிஸ் பண்ணுறது என்னதுன்னா, இந்த பாப் இஸ் ட்ராவலிங் இன் த ஏர். ஓகே, இந்த இடத்துல ஏர் இருக்குது. ஸோ அது மேலே ஒரு ஃப்ரிக்ஷனல் ஃபோர்ஸ் ஆக்ட் ஆகும். ஸோ அந்த ஃப்ரிக்ஷனல் ஃபோர்ஸ்னால இது வந்து இந்த லோவஸ்ட் பாயிண்ட் வரும்போது அதோட இனிஷியல் எனர்ஜியில் பாயிண்ட் that is 5% it will lose. Okay, so 5% is nothing but 0.05. Okay, so 5 by 100 or 0.05 of its initial energy. Okay, so when the bob reaches the lowest point, it loses 5% of its initial energy. Okay, so அதுதான் வந்து ஈக்குவல் டு த கைனெட்டிக் எனர்ஜியாக இருக்கும். ஓகே, ஸோ நம்மளுக்கு இனிஷியல் எனர்ஜியிலேருந்து 5% we have to subtract. That's the energy at which it reaches this lowest point, which is also equal to the kinetic energy. Okay, ஸோ அதோட இனிஷியல் எனர்ஜி எவ்வளோ, mgh. ஓகே, ஸோ நம்ம இங்கே g வந்து 9.8 எடுத்துக்கலாம். ஸோ g equal to 9.8 meters per second square, acceleration due to gravity. ஸோ இவங்க வந்து மாஸ் வந்து கொடுக்கல, நம்ம எம்னே வச்சுக்கலாம். அண்டு ஹைட் வந்து இஸ் 1.5 meters. தேர்ஃபோர் நம்ம ஸோ இதோட இனிஷியல் எனர்ஜி வந்து இஸ் m into 9.8 mg into h is 1.5. ஓகே, ஸோ இந்த இனிஷியல் எனர்ஜி வந்து ஸோ இது வந்து ஈக்குவல் டு த நம்மளோட கைனடிக் எனர்ஜி ஆஃப் mv எஃப் ஸ்கொயருக்கு ஈக்குவலாக இருக்கணும். ஆனால் என்னன்னா டியூ டு இட் ட்ராவலிங் த்ரூ த ஏர் இட் லூசஸ் 5% ஆஃப் இட்ஸ் இனிஷியல் எனர்ஜி. ஓகே, ஸோ அப்போது இதுதான் வந்து டோட்டல் எனர்ஜி, இனிஷியல் எனர்ஜி. அதிலிருந்து we have to subtract 5%. ஓகே, therefore minus 5% is 0.05. 0.05 of the initial energy. So இந்த quantity திரும்பி எழுத வேண்டியதுதான். m into 9.8 into 1.5. This must be equal to the final kinetic energy. Okay, so நம்மளுக்கு இப்போ we can strike out mass on all the sides, on both sides. ஸோ அதனால தான் இவங்க மாஸ் கொடுக்கல, நம்மளுக்கு தேவையில்லை. So the if we solve the remaining part, we have 9.8 into 1.5 minus 0.05 into 9.8 into 1.5 equal to, let me write this as 0.5 of Vf square. Okay, of is 0.5. So in the numbers we have to calculate. Okay, so I have already calculated that value. So this is 14.5, 14.7 minus 0.735 equal to 0.5 of Vf square. We are interested to find Vf. Okay, so we can bring this 0.5 this side. Therefore, 15.7 is 13 point. If we subtract, we will get 13.965. We can bring this 0.5 this side. Therefore, divided by 0.5 equal to Vf square. Okay, so this divided by 0.5 is 27.93. Okay, this is the Vf square. We have to take roots. So Vf equal to root of 27.93. Okay, root of this quantity is 5.28, okay, meters per second Vf, or you can round it off as 5.3 meters per second. Okay, this is how you have to solve this problem. So this is the next problem. The statement of the problem is a trolley of mass 300 kg moving a sandbag of 25 kg. Carrying a sandbag of 25 kg is moving uniformly with a speed of 27 kilometers per hour on the frictionless track. So the clue are here: uniformly and frictionless track. Okay. After a while, sand starts leaking out of the hole on the floor of the trolley at the rate of 0.05 kg per second. What is the speed of the trolley after the entire sandbag is empty? Okay, so this problem may look like a big problem, but this is not at all a thing. It's an intuitive problem. Okay, so the whole system is in uniform motion. Okay, that too on a frictionless track. Therefore, the initial velocity will be equal to final velocity. Okay, so this is a trivial problem. So I took this problem to convey that I will skip this kind of trivial problems in the future class. Also, I have skipped other problems in the previous video. Okay, so this is the reason. So if it is trivial, I will skip. Okay, so if the problem involves some kind of trick or some kind of physical concepts to be shown upon motto, I will explain. Okay, till or else I will just skip that those problems which are very trivial. Okay. So நம்ம next problem பார்க்கலாம். Next problem வந்து 5.12, 5.2, 5.20. So let me add the problem. So let me complete the statement for this problem. Since the system is in uniform motion on a frictionless surface, the body continue to move the the same speed forever. Okay, unless anything stops it. Okay, this is from Newton's first law. Therefore, the final kinetic energy, the speed of the trolley after the entire bag is empty is equal to, which is the initial velocity, which is initial speed, which is 27 kilometers per hour. Okay, so this is the statement. Okay, so let's move on to 5.2 problem. Let me add that statement. So this is the problem statement. A body of mass 0.5 kg travel in a straight line with velocity which is given by a function of x, v equal to a x power 3 by 2, where a equal to 5 meter of minus of and s inverse. What is the total work done by the net force during its displacement from x equal to 0 to x equal to 2? Okay, so here we are going to exploit the idea of conservation of we are going to use the idea of work energy theorem. Okay, by work energy theorem, we know that the work done by the net force equal to change in kinetic energy. Okay, so this change in kinetic energy is nothing but kf minus ki. So this kf is the velocity final velocity, and this is the initial velocity. Okay, so we have v velocity in the as a function of x given by a x power 3 by 2 with a equal to 5 root uh, m power minus 1 by 2 s power minus 1. This is the unit. Okay, so we have to in order to find the initial kinetic energy, we need to know of m v xi. Okay, so xi is also given, it's 0. X final is 2 meters, I think so. Okay, so 2 meters, so 0 meters and 2 meters. Okay, so uh, so in order to find the initial kinetic energy, you have to replace x by xi. Okay, so v of xi square. Okay, similarly final kinetic energies of mv of xf square. Okay, so இது ரெண்டுத்தையும் நம்ம கண்டுபிடிச்சோம்னா we can find delta f, thereby we can find the work done by the net force. Okay, so நம்ம first இப்போ v of xi கண்டுபிடிப்போம், where v ன்றது இது. Okay, velocity. V of xi equal to 5 into, instead of a I put 5, and x we have to put 0 power 3 by 2, therefore this is 0. Okay, therefore initial kinetic energy is of m into 0, which is 0 square, which is 0. Okay, so this is the initial kinetic energy. Similarly, we have to find the final velocity, that is at position x equal to 2. Therefore, 5 into 2 power 3 by 2, which is equal to, so we can write this as it is equal to 5 into uh, 2 into root 2. Okay, 2 power 1 into 2 power 1 by 2, this is 3 by 2. So 1 plus of 1 and half, which is nothing but 3 by 2. Okay, so we can therefore write v of xf equal to 5 into 2 is 10, and 2 power 1 by 2 we can write it as root 2. Okay, so we can find the final kinetic energy as of m. Instead of v xf square, we have to put 10 into root 2 the whole square, which is equal to uh, of m. Instead of m we have point 0.5, I think so. Yeah, point 0.5. I missed the quantity here. M equal to zero point 0.5 kg. Okay, so here also we have to put zero point 0.5, but it doesn't make any difference. Okay, so inge number we have to put zero point 0.5. So 0.5, so it will become 100 into 2. Okay, if we square, then we get 100 into 2. So this and this cancel. So zero point 0.5 times 100 is 50. Okay, so 50 joules. So kf is 50 joules. So we have ki and kf. So here we have ki equal to 0 joules. So since we know that the initial and final kinetic energy, we can find the change in kinetic energy, which is the work done by the force. Therefore, the work done by the force W equal to Kf minus Ki, which is equal to 50 minus 0, which is equal to 50 joules. Therefore, the work done by the force is 50 joules. So let's move on to problem number 5.21. So this is the statement of the problem. So the blade of a windmill sweeps out a circle of area A. If the wind flow at a velocity v perpendicular to the circle, what is the mass of air passing through it in time t? What is the kinetic energy of the air? Assume that the windmill converts 25% of the wind energy to electrical energy, and that A equal to 30 meters square, B equal to 36 kilometers per hour, and density of air is 1.2 kg per meter cube. What is the electrical power produced? Okay. So let's start with the diagram so that it will be easy for you. So this is the windmill. So it has an head here. So this head will rotate. Okay, this will rotate, and these are the fins. This is the fin. Okay, let me draw a circle. So this fin rotates in this direction, so it sweeps out a circle given by this. It looks similar to like this. Okay, so this is the circle swept out. Okay. So actually we are viewing in this in the side view. Okay, so if you view in this direction, that is in this direction, then it looks like a circle. Okay, so it looks like a circle. Okay, so this is the view for if you view through the direction of the wind. Okay, so this is the direction of the wind. So the wind is coming this way. Therefore, the wind is perpendicular to the this area swept. Okay. So this wind is perpendicular to the area swept by the circle. Okay. So this wind is perpendicular to the circle. So this area is A. This area of the circle is given by A. Area of circle on the A. They have given it. So they are asking to find the volume of the air passing through it in time t. Okay. So if the air starts here at a time t equal to 0, it at and the time t equal to some later time t equal to t. Okay, so this is the later time at t. So it will travel this distance. This distance is equal to, we know that velocity equal to distance by time. Okay, so therefore the distance travel should be velocity into time. Distance travel should be equal to velocity into time. Therefore this distance will be v into t. Okay, so they are asking to find the this volume. Okay, so this volume. So we know the area of the circle, okay, and we also know this distance. Okay, it's a cylindrical volume. So we can find the volume as volume equal to area into this distance given by V into T. So volume of air which passes through the area A sweep by the blade is given by, this is equal to, this volume is equal to area into that length, and that d is nothing but area into velocity into time. Okay, so in time t. Okay, so this is the volume v, capital V. Okay, so next they ask to find the mass. I think so. uh, if the wind flows, what is the mass of the air passing through the in time t. Okay, so we know the volume of the air which sweeps through the area in time t. This is given by v equal to a into, where a is the area of the circle, v is the velocity, and t. Okay, so in order to find the mass, we know mass equal to uh, or we can write density equal to, from density we can derive density equal to mass per volume. Okay, so they have provided the density of the air. Density is rho, mass is m, and the volume is v. Okay, since we know the volume, we can find the mass. Therefore mass of the air which passes through the area A in time t is given by m equal to, or small m equal to density times volume, rho times volume, and we have volume which is area times velocity into the time. Okay, so this is the mass of the air. Next, they asked to find the kinetic energy of the air. Okay, so it's B. They are asked us to find the kinetic energy of the air. Okay, so let the kinetic energy K equal to of mv square So we have to substitute the value of mass here. Therefore we have of, instead of mass we can put rho into a into v into t. Okay, we have another v square. Okay, therefore the kinetic energy of the air equal to of rho a v into v square v cube t. Okay, so this is the kinetic energy of the air. Next they asked to find us the power generated by this air wind, uh, electrical power produced by the wind. They have provided some values for our calculation. So they have given the area A equal to 30 meters square and velocity equal to 36 kilometers per hour. We have to convert it, and the density equal to 1.2 kg per meter cube. What is the electrical power produced? We have to find the electrical power. We also provided the efficiency of the windmill is 25%. So the efficiency is 25%. Eta equal to 25%. Eta is the they have provided that the windmill converts 25% of the wind energy into electrical energy. They are asking to find the electrical energy, not the wind energy. Okay, so whatever the energy produced by the wind through this kinetic energy should be the quarter of that energy will be the uh, uh, electrical energy. From that we have to find the electrical power. We asked to find the electrical power. So power is work done by time. Okay, so this is what we are going to find. Power P. Power P equal to work done by time, and that work done is nothing but the change in kinetic energy. In this case is the kinetic energy. So power P equal to, we have the kinetic energy which is of rho A V cube T. So the power, this T and T goes, therefore the power equal to of rho A V cube. Okay, so this is the power of the wind. Okay, we not yet converted to electrical power, we just found the value of the wind power. So 25% is nothing but 0.25. Okay, so electrical power equal to 25% 5% of the wind power. Okay, so this is the wind power, which is 0.25 into EW. It's the electrical power generated by the windmill. So therefore we have 0.25 divided by 2 rho A into V cube. Okay, so this is the electrical power. So we have rho equal to 1.2 kg per meter cube. We have the density of air. Area equal to, they have provided as 30 meters square, and velocity equal to 36 kilometer per hour. Okay, we have to convert to meters per second in order to get the units in SI system. Okay, so SI in power is watt. So what we have to do is 36 kilometers per hour into, let's convert kilometers to meter. So we have to multiply by 1000 meter divided by 1 kilometer. Okay, and for hour we can convert to minute. So 1 hour by 60 minute. Again, we have to convert, so this minute into 1 minute is 60 seconds. Okay, therefore we have, so this hour and so this kilometer and this kilometer goes away, this hour and this hour goes away, this is minute. Okay, so this minute and this minute goes away, so we end up with the meters per second. Therefore 36 into 1000 divided by 60 into 60, 3600 meters per second. Okay, so this is equal to 10. So the velocity is 10 meters per second. So V equal to 10 meters per second. So we are ready with the values needed to find the power or electrical power. Okay. So electrical power P equal to 0.25 divided by 2 into 1.2 into 30 into, we have VV cube, so 10 cube. Okay, so if you solve this you get 4500 watt. Okay, so this is the electrical power, or we can write it as 4.5 kilowatt. So this is the electrical power generated by the windmill. Okay, so this is the wind power generated by the windmill, and this is the electrical power generated by the windmill.